In today's video, we will see some more numericals based on this radiation. So already we have seen 6 numericals. This is our numerical number 7. So whatever the formulas that we have discussed from numerical number 1 to numerical number 6 will be utilized in this numerical. So this is the additional numerical that we are taking. So let us go for this numerical and see what data is given to you and what you have to calculate. So in this numerical, if you can read from this numerical, a short current element, see a short current element of length lambda by 20. So current element का आपको length दिया हुआ है. So current element acts like an antenna, and whenever the current element will be given to you or the length of the current element will be given to you, you have to remember that the length of the current element is always the effective length, right? And the effective length is given to you, and that is given to lambda by 20. So that is the length of the current element is given in terms of lambda. It is not specified the numerical value, but it is given in terms of lambda. So need not to fear, this lambda will get cancelled in the formulas, right? Then carries a current of 10 ampere. 10 ampere आपका current दिया हुआ है, and always this current it is called as the RMS current, or it is also called as the effective current, right? At a frequency of 10 megahertz, the frequency is given to you, that is 10 megahertz. I will collect the frequency data here. The frequency is equals to 10 megahertz. And I have already told you that whenever the frequency will be given to you, first you need to convert that frequency into the wavelength, because in radiation numericals you will require the lambda, right? So you need to convert the frequency into the lambda. See what you have to calculate. You have to calculate the electric field intensity at a distance of 2 kilometers. At a distance of 2 kilometers. So in this unit, the distance is represented by small r, और small r कितना दिया हुआ आपको 2 किलोमीटर दिया हुआ है. So you have to convert this 2 kilometer into the meter, or whenever you will put this value in some formula, you have to convert this 2 kilometers into meter. The 2 kilometer is nothing but your 2000 meters, you know, right? Also calculate the radiation resistance. तो यहाँ पे दो पैरामीटर निकालना है. एक निकालना है आपको इलेक्ट्रिक फील्ड इंटेंसिटी और दूसरा निकालना है आपको रेडिएशन रेजिस्टेंस. ये दोनों फॉर्मूले हमने इसके प्रीवियस न्यूमेरिकल में हमने देखा हुआ है. सो what I will do here, first I will calculate the wavelength, and wavelength के लिए already मैंने बताया था फॉर्मूला का यूज करना है V divided by F, और wavelength can also be represented as C divided by F, where C is nothing but the velocity of light. So why we are considering in the velocity of light? Because we know that the electromagnetic waves travel with the velocity of light, right? That is the velocity of propagation of electromagnetic waves is always equal to the velocity of light. So that's why for velocity, we will always take this as 3 into 10 raised to power 8. And frequency is given to you, that is 10 into 10 raised to power 6. So when I will divide these two value, I will get the wavelength that is equals to 30 meters, right? Now, as we have to calculate the electric field intensity, we have to use the formula for the electric field intensity. So in previous numerical also we have used the formula for the electric field intensity, and the formula for this electric field intensity is 120 pi divided by r, here r is distance, into I RMS. तो here you have to consider the RMS current. न्यूमेरिकल में जनरली आपको RMS करंट ही दिया रहेगा, वो करंट की वैल्यू आपको यहाँ पे पुट करना है, multiplied by L effective divided by lambda. So this is the formula for electric field strength, or you can say simply the electric field. So simply you have to put the value. The RV is given to you, current is also given to you, and L effective is also given to you, and L effective is given to you in terms of lambda. So when I will put all the values, R is equals to 2 किलोमीटर दिया हुआ है, तो 2 into 10 raised to power 3. RMS करंट दिया हुआ आपको 10 amperes, और इफेक्टिव लेंथ दिया आपको lambda divided by 20. So here you can say this lambda will get cancelled, and if you calculate this value, the electric field strength is coming to be 0.0949. So you can also write down this electric field intensity in terms of millivolt per meter, as if I can write down here, this will become 94 into 10 raised to power minus 3, 94.9 here into 10 raised to power minus 3 volts per meter. So you can write down this electric field strength as 94.9 millivolt per meter. So also you can express this value in millivolt per meter. अगर नहीं करते हो तो भी कोई दिक्कत नहीं है. So easy is this parameter. Now next we have to calculate the radiation resistance. So the formula for the radiation resistance we have seen many a times in the previous numerical. So the radiation resistance formula for current element is 160 pi square multiplied by L effective divided by lambda whole square. So 160 pi square is constant. I will put the value of L effective as lambda by 20 divided by lambda. So again here lambda will get cancelled. It will become a simple calculation, and if you calculate this value on calculator, the radiation resistance will come to be 3.95. So this numerical is also easy. Just you need to remember the formulas. It will be easier for you, right? So that's all for this video. Thank you very much.